So in this video, I'm going to do some example problems where we use inverse trig functions to find various things. Okay, so the first one I want to look at is something like number 1 right here. We're given two sides of the right triangle, 40 and 42. And what we're missing, what we're looking for, is this angle down in the corner. I'm going to do this problem a lot like we do the problems where we the problems that we use sine, cosine, and tangent on. I'm going to start by labeling the sides of my triangle opposite, adjacent, hypotenuse from the perspective of the angle that I'm looking for down here. So from there, 40 is my opposite side, my adjacent side is down here, and my hypotenuse is right here. Okay, so if I know opposite and I know hypotenuse, then I'm going to go ask SOHCAHTOA and say, Mr. SOHCAHTOA, which one of my ratios involves opposite and hypotenuse? And he's going to tell me, of course, that sine does. So sine of this mystery angle equals 40 over 42. Right? So these kinds of problems where we use inverse trig, we know the ratio. What we don't know is the angle. So we use inverse sine to find, or inverse cosine or inverse tan, to find the angle when we know the sides, when we know the ratio. Okay, so I've got sine of this angle equals 40 over 42. That tells me that the angle itself is going to be inverse sine negative 1, of 40 over 42. Now I'll go to my calculator here, and I'll do inverse sine of that second sine, 40 divided by 42, close my parentheses, hit enter, and I get 72.2 degrees. And I'm done. I found the angle. Let's do another example. Let's look at number 5 right here. Okay, so I know, here's the angle that I'm looking for. I know that this side is 4, this side is 5. So from the perspective of this angle here, opposite side is over this side, down here is my adjacent side, and this is my hypotenuse. Adjacent is what I know, hypotenuse is what I know, adjacent and hypotenuse is cosine. So cosine of this angle that I'm looking for equals 4 divided by 5. It tells me that the angle itself, the angle measure itself, will be the inverse cosine of 4 over 5. I know what cosine is, and I want to find the angle. Go to my calculator, second cosine, 4 divided by 5, and I get 36.9. So this angle down here, the missing angle, is going to be 36.9 degrees. Now another kind of problem we have is something like this, where we're asked to solve a triangle. Now this means, solving the triangle means finding the measure of every side and every angle in the triangle. So let's look at number 20 over on this side. I'm given angle B is 62 degrees. I'm given that the side across from B is 22.6 miles. Now, of course, I also know one other thing, right? I know that this is 90 degrees. I know it's a right triangle, so that's important, because that means I can use sine, cosine, tangent, all that stuff. But I also know this is 90 degrees, which is going to help me find the missing angle. I know that this angle plus this angle plus this angle have to add up to 180 degrees, which means that angle A has to be 28 degrees. Okay, now I want to find the other two sides. I'll just call them X and Y. Doesn't matter what I call them, obviously. And I'm going to pick one to find first. Once I know 62 degrees is here. I also know this is 28. I'll use 62. And from the perspective of 62, I'm going to circle it just so I remember which one I started at. I'm going to label the sides. So this would be opposite. This would be adjacent over here, the one that I'm looking for. And this would be hypotenuse. Okay, so I know opposite. I'm looking for adjacent. Opposite over adjacent is tangent. So tan of the angle, and I know what the angle is, so I will fill this in, right? I know it's tan 62, is what I'm looking for, equals 22.6, that's the opposite, over the adjacent side, which is X. I call it X, I'll just write X here too. Okay, now we talked about before, algebra, a little algebra trick, I can switch these two around, which means that X is going to be 22.6 over tan 62. And I'll put that whole thing in my calculator so I don't have to worry about losing stuff when I round. So 22.6 divided by tan 62. I get 12.0 miles. So this side over here is going to be 12.0 miles. I want to find, one thing I'm still missing is the hypotenuse. I could do this in a number of different ways. I could set up another trigonometric equation. I could say, for instance, that sine of 62 is 22.6 over y. I could say, cosine of 62 is 12.0 over y. I could say, I could use 28 degrees. I could say sine of 28 degrees is 12.0 over y. Or I could do what I'm actually going to do, which is just use the Pythagorean theorem, because I've got a right triangle, and I know the two legs, so I know that the third side, the hypotenuse, is going to be the square root of 12.0 squared plus 22.6 squared. I'm going to put that into my calculator, and I'm going to use my unrounded answer that's still in the calculator here. I'll do it like this. So do the square root. And then I'm going to use my previous answer. The way I do that is I press second, then press the negative button down here. What happens? I get answer. That's my answer. Close my parentheses. Squared plus 22.6 squared. That's my other, wait a second. Got extra parentheses in there. Alright, so this is my A, my B, so the C is going to be the square root of A squared plus B squared. I hit enter, and I get 25.6. So the hypotenuse here is going to be 25.6. So I've got my two sides, I've got my third angle, and I'm done.